Here we're asked to determine the rational roots of the polynomial. So first thing, before even we start finding possible rational roots, we want to think about all of the ways that we know how to factor to see if any of those will help us. First of all, greatest common factor, we got nothing there. Is it a quadratic? No. Is it sum or difference or some other difference of cubes? No. A difference of squares? No. None of that really helps. We could try factor by grouping, but if we start factoring by grouping, we'll quickly see that that's really not going to help us either. So then now we got to go ahead and find all of the possible rational roots. So when we look at this, possible rational roots are the constant or the factors of the constant, so plus or minus 1, 2, and 4. And then over the factors of the leading coefficient, which is just 1 or 3. So all of my possible rational roots here is going to be plus or minus 1 over 1, 2 over 1, 4 over 1, then 1 over 3, 2 over 3, and 4 over 3. So those are all my possible rational roots. Done with that. Now we got to start plugging those in to use synthetic substitution. So to start us off, I like to start with the easy ones, so whole numbers first. And don't you just love it when it helps on the first try? We plug in positive 1 and we get 0 here. So then once we've found a 0, we want to factor out that binomial. So what that means, if positive 1 is a 0, then I know that x minus 1 is a factor of this long polynomial here. So I'm going to factor that out, and what's left is what I got from synthetic substitution. So that becomes 3x squared plus 8x plus 4. Now again, I want to pause really quick and double check, can we factor anything out using a greatest common factor? No. Is it a quadratic? Yeah, but I don't want to factor that big thing there. And is there anything else that we can do? No sum of squares, or sorry, no sum of cubes or difference of cubes or difference of squares, no factor by grouping. So I'm just going to continue on. So I'm going to use negative 1 here to see if that works. Let me go ahead and change colors here so we don't mix them up. So you'll notice that I used this string of numbers here with synthetic substitution going forward, so I can continue using that. But this one here did not give me a 0. So next I'm going to go ahead and try, I'm actually going to try negative 2 and not positive 2, because I notice these are all positive numbers here. So if I keep plugging in a positive number, multiplying and adding is never going to get me down to 0. So negative 2 here, 3, 8, and 4. And negative 2 looks like it gives us a 0 here. So again, I'm going to factor that out. So remember, I still have x minus 1 factored out. Now I have x plus 2, because if I plug in negative 2 into there, it's going to give me a 0. And what I'm left with is 3x plus 2, because that's what I get from here. And now I know my zeros. This is the factored form of this polynomial, and I know my zeros based off of each of these factored forms here. So I know positive 1 is a 0. I know negative 2 is a 0. And then really quickly, just to show you if you're not sure how to do this one here, to see what is equal to 0, I am subtracting 2 from both sides. I get 3x equals negative 2. Divide both sides by 3. So I get x is equal to negative 2/3. So my 3 zeros here, or my possible or my rational roots here, are 1, negative 2, and negative 2/3.